This episode of Mike Plays RP-1 will see the modification of the XASR-1 sounding rocket to allow it to be safely recovered after it has traveled into space. I'm going to use this as an opportunity to introduce some flight automation using the mod Kerbal Operating System. This will involve going over how to access and run programs through the mod's terminal window, as well as writing a simple program that will, nevertheless, fully automate this mission. Let's get started. The conclusion of the last episode saw the completion of the first low space film return contract, which means I have to pick up another one. And I'm thinking about just working my way down the contracts in the Suborbital rocket development program. If I finish this off, I'll have room for the X-Plane research program, which will really give my pilots something to do. So our next contract would be reach a suborbital trajectory and return uncrewed. This contract requires us to reach an altitude of 140 kilometers. I already have the XASR-1, also from last episode, that can reach that altitude, but it then has to return home safely. So it should be simple enough to just modify that rocket with some parachutes from the Real Shoot mod so that it will softly touch down on the surface. I'll get to that soon, but first I want to take a quick look at an upcoming tech node, Post-War Materials Science. There's some good stuff in here, but right now I want to draw attention to the Engineer Efficiency upgrade, which increases the minimum efficiency of the launch complexes by 3% and maximum efficiency by 5%. For example, if we take a look at our engineers in Launch Complex 2, we can see they are working with an efficiency of 25%, which is at the current maximum. Basically, the more you use the launch complex, the more efficient the engineers become. That efficiency upgrade would have the maximum go up to 30%, allowing me to do my builds more quickly. So let's move Post-War Materials Science up on the research queue. Supersonic plane development is so close to completion that I don't want to mess with it, but we can make Materials Science the next one after that. So we got supersonic planes in just over a week, and Materials Science in a little over 7 months. But with that, let's go to Launch Complex 1, where the XASR-1 is nearing completion, and see if we cannot modify it so that it can be recovered. Now, one thing I mentioned last episode is that there is an upgrade for the Tiny Tim booster, but not really. There's just a different version of it. So like if I go to the engine GUI for the Tiny Tim here, we are in the, I guess this is 30 kilopounds of force? I guess, I'm not sure. But anyway, we have this guy which can do 50 whatever kilopounds of force. Someone will tell me what that really means. But I'm gonna, if I switch to this, it ups the amount of thrust dramatically, but notice the burn time goes down. So it's just a different version of the nozzle or the grain or whatever, so it burns hotter and faster. I'm not convinced this will get me anything worthwhile, but it is certainly worth a test in simulation mode. A lot more of a kick at the beginning. It survived the kick, so that's good. But I'm not convinced this will result in a higher altitude, which is what this is all about. Just to remind people, on the previous version of the booster, we reached an altitude of around 144, 145 kilometers. And to be clear, this isn't an upgrade I've unlocked. This version of the Tiny Tim was available from the beginning. I just missed it. But after the engine flamed out and I got myself high enough that my apoapsis was no longer dropping, I realized that I was going to reach an altitude of over 152 kilometers. Well, I guess I'll stick with this higher thrust booster then. While on the topic of boosters, it was pointed out by a viewer that the real-life version of these rockets would have ignited both the booster and the Aerobee engine together at launch. Not only does this eliminate the ullage problem, igniting the Aerobee engine while under the very high thrust of the Tiny Tim booster increases the chance of an ignition failure. Apparently, this is modeled in RP-1, but I couldn't detect any differences in the chance of a failure, while igniting both engines at the same time did reduce the altitude reached. So I decided to stick with my staging method for now and see if any problems develop later. For the parachutes, I used the same part from the Real Shoot mod that I used for the V2 rocket last episode. This time though, I figured it was simpler to recover the whole rocket rather than detach the payload. This part is scalable down to the 300mm diameter of this rocket. I didn't realize this at the time that the mod does a lot of work for you to calculate the parachutes that you need. Here, I worked out the dry mass of the rocket, that is the mass without propellants, and inputted it in manually. But I now realize that if I had left it on use current mass, the default is for it to use the vessel's dry mass anyway. It's automatically there. Other than that, I left everything else on the defaults and just hit apply settings. The extra mass of the chutes has me now coming just shy of the necessary 140 kilometer altitude. However, though terrifying, the parachutes worked perfectly. Though I did realize that I would likely be better off getting this thing to drop into the water. So, in the VAB, I tilted the rocket a tiny bit to the east, and, to get more altitude, I increased the length of the fuel tank bit by bit, seeing if a little more propellant can squeeze some more out of the Aerobee engine, and changing the length from 4.6 meters to 4.9 got me the altitude I needed. To reduce the stress when the parachutes deploy, I reduced the mass strength multiplier on the tail fins from 0.2 to 0.15%. This had them exploding during descent, making the rocket aerodynamically unstable, causing it to lose a lot of speed ahead of the parachutes deploying. With the rocket now performing the way I like, I thought this might be a good time to introduce some simple flight automation using the mod Kerbal Operating System. This is another mod that is not part of the RP-1 package. If you want it, you have to install it separately. kOS programs are accessed through a terminal. To get to the terminal, you just gotta find the kOS icon in your menu bar and then click on the little terminal button right here. You interface with your programs through this terminal, which is deliberately old school, which can be a bit intimidating at first. So we're just going to do some introductory stuff today, but by the end, we will have a working program that will fully automate this mission. kOS uses an in-house, full-on programming language called KerboScripts. The programs you write can be stored right on the vessel or at the Space Center archive. We'll deal with putting stuff on the rocket in a future episode, but for now we need to realize that the terminal is set to be accessing the rocket. To get it to access the archive, all you have to do is type in switch to 0 and then hit return. Always end every kOS command with a period. You got to get used to that. And now we are on 0. If we want to go back to the rocket, we type switch to 1, and that puts us back on the little kOS program that's in it's actually built right into the avionics package. And by the way, if there are more than one kOS core, then you actually will get 1 and 2 and 3 all the way down the rocket, depending on how many there are. But 0 is always the archive. So let's switch back to the archive. Switch to 0. Again, period at the end. You'll get used to that. And we can see everything that we have stored here by typing in the command list. Period. And there we go. And of course, right now we have absolutely nothing here. And it says free space remaining is infinite. That's because the actual space it's using is my computer, which I suppose technically isn't infinite, but compared to the rocket that we have here, it certainly is. And actually, just to show you, if I switch back to the rocket, switch to 1, and go list. Again, there's nothing here, but notice here, it only has 400, and I am pretty darn sure that's 400 bytes. At the most, it might be, no, I think it's 400 bytes. That's a teeny tiny little program. You know, we're working like in the 1950s now, right? So you cannot store a sophisticated program. That's another reason to be running this from the archive. So one more time, switch back to the archive. So that is 0. So what I'd like to do is write myself a program. Right now there's nothing here. Normally I would do this with an external editor. Any kind of text editor will do. I personally use Notepad++, which is really light and really simple to use, but you can pretty much use anything. So if you have your favorite text editor, if you do a lot of this kind of stuff, then by all means just use that. But for this video, I'm actually going to use the built-in editor that's built right into it, and to access it we type in edit, and then we type in a name for our program. We're going to name it right here. We're going to call this program the XASR1 right after our rocket, and not surprisingly, period at the end, and that opens up an editing window down here at the bottom. We'll just open this up, make it a little bit, it doesn't need to be any bigger than that. And you can see here it's telling me I am in the archive and that my program is called XASR1. Okay, so let's put in some sort of a command for our program to run. We'll start with the simplest thing. We're going to stage our rocket. So we're going to put in the word stage. Now, actual kOS commands are all case insensitive. Whether you want to do this in lowercase or uppercase or any kind of mix in between makes absolutely no difference. But I like using the keywords that are built into the language with all uppercase letters. That's just a formatting style that I have picked up. If you would prefer this to be lowercase, by all means, go ahead and do that. Now, I need to actually make this terminal window bigger again. There we go. And find out where is our cursor. There's our cursor. Okay, now to run my program, it's actually very, very simple. I simply say, well, first of all, I should save it, shouldn't I? And this, by the way, just got saved onto your computer somewhere. Well, actually, I'll show you where a little later. But for now, we're going to run XASR1 dot. And there it goes. And then absolutely nothing happened. Well, of course nothing happened because one of the requirements, let's pause this thing before things get worse. One of the requirements for this particular rocket is that the throttle be set to full, and the throttle was at 0, so our Aerobee engine never lit. Okay, that's not a problem. So what we'll do is we will revert back to restart the simulation. And unfortunately, we have to go through and find our terminal window again. We got to switch back to the archive again, so that's switch to 0. I forgot the word 2. 0. There we go. And if I hit list, by the way, just some people that are kOS veterans will know there's quicker ways around this. There is a little directory here called boot, which is a folder on your computer, and I'll show you how that works when we actually go to fly this thing for real, which one of the things I can use it to do is to take away me having to go through and do all that manually every single time. But for now, that's okay for me. So let's edit our XASR1 to bring up our editor, and you can see that because I saved it, my stage command is still there. Okay, part of the problem was that the throttle was set to 0, and of course that means the Aerobee's not going to go. So what I need to do, the command to go to full throttle is to lock. Again, I'm going to go uppercase for me, throttle to 1. That is the command to lock your throttle to 1. And if I take out the stage command, which by the way, you can use a double slash. A double slash is a way for you to put in a comment. You can write anything you want after the double slash, and the computer will ignore it. But this is a way for me to get it to ignore that part, just so I can get it to show you that this part works here. So we will save this, and we'll go run XASR1 bop bop. And you can see here, oh, the program has ended. Aha, that's right. I should have realized that's going to happen. And why did that happen? Well, because when the program gets to the end, it only had one command, which it does in just like a few microseconds. And then the program ends, and then it dumps out of the program, and the game will revert it back to the state it was before the program ran. So the program ran for some tiny fraction of a second, and then the throttle went right back down. It ran for so briefly you didn't even get a chance to see the throttle go up. So I'm going to put another command there, go wait, let's say 3 seconds. So this is a command here, wait. If you put a number after it, it understands that as seconds. Okay, we're going to save that. Run again. Run XASR1, and now throttle goes up, we're going to go for 3 seconds, it's waiting, and then after the 3 seconds the program ended and it reverted back to its state. So let's kind of puzzle this together, how this is going to work. So if I go back to my stage command and take out this wait, probably some of you are realizing this isn't going to work, because it's going to lock the throttle to 1, it's going to stage, and then the program is going to end. The throttle will go back to 0, so by the time I actually need that aerobee, the program is done, and the throttle's still going to be at 0. So what I'm going to do is I'm going to put in a little command here to just say, wait, oh, I don't know, like 10 seconds. Okay, save that. Let's run that. Run XASR1. Boom. There we go. And it did it. See, it did that part. But you might be guessing, after 10 seconds of this programming running, it's reverted back and the throttle's gone down and we're in a bit of a pickle. So let's once again go back. Okay, so here's our program right now. This wait is not really doing it for me. Now I suppose you could get there and figure out, well, how many seconds is the aerobee going to run for, and then put in more seconds than that. But that's not particularly satisfying. It would be really nice if the rocket would be able to tell when it would be an appropriate time to end the program. And there's all kinds of things you can do with triggers, things that the rocket can detect, that the program can detect, that will say, oh, when you get to a certain situation, that's when I want you to do this. That's how you can get programs to actually do different things in different situations, kind of make their own decisions. It's kind of what makes a program instead of just following one by one. So, what would be a nice condition for this program to end? Well, I'm thinking, what if I just waited until it got all the way to the very, very top, to its apogee, and then the program to end? By then the aerobee is clearly going to be done. So how can I get it to wait until apogee? Well, right now the program doesn't know what its apogee is going to be, and quite frankly it varies a bit. I don't know what the eventual apogee of this rocket is going to be, but what I do know is after it passes its apogee, it starts coming back down, and its vertical velocity is going to switch from positive to negative. So if I wait until the vertical velocity becomes negative, I know that the rocket is then on its way down. So I'm going to type in the command wait until, and vertical velocity is actually vertical speed. You have to get these words exactly right, is less than 0. And so and again, a period at the end, that's the easiest thing to forget. So when it gets to this line, it's not going to do anything. It's going to sit at this line, the program, until our vertical speed becomes a negative number, something that's less than 0. And then in this case, the program will end because there's nothing after that. Now, all this stuff is impossible, well, not impossible, but very difficult to memorize. There are so many, hundreds and hundreds of kOS commands and constants and things like that you want to learn. There's no way to learn them all. There is an excellent documentation page for kOS. I'll put a link down there in the description. Basically, whenever I'm writing programs, I'm having that up beside me so I can just look up things like, okay, how do I get vertical velocity again? Oh yeah, it's vertical speed. I look that stuff up. I don't memorize it, and so should you. But let's take a look to see how this works. So we're going to save that, and we're going to once again run our XASR1 program, and boom, off it goes. And now this aerobee engine is going to continue to keep at full throttle until we're starting on our way down. Okay, so we now actually have a program that's doing half the mission. It'd be nice maybe for it to, I want to fully automate this, maybe deploy the parachutes and do stuff like that. Well, you know, once we've waited until our speed is negative, that might be a good time for us to arm our parachutes. So I'm not going to do all that now. Instead, a little later in this video, we'll actually fly this mission for real. And at that time, I'll go through the program that I ended up writing, and I'll go through it step by step by step. Shouldn't be any problem for you to understand it at that point. But in the meantime, there's plenty of other stuff going on besides this rocket. The contract after going suborbital and recovering is to reach a downrange distance of 3,000 kilometers. So I thought it would be a good idea to get something going that could handle that mission. This basically involved putting an XASR-1 atop my V2 rocket, and although I was pretty pleased with some of the downrange distances I did get, I soon realized that going 3,000 kilometers downrange represented a substantial leap forward. Even if I managed a build that would work, it would take a very long time to construct. You were better off going up in incremental steps, so I abandoned the downrange contract for now and instead focused on modifying my V2 to perform the low space film return contract, which is just a small step up from the contract it completed last episode. I did, however, write another, more sophisticated kOS script to automate the mission, which will be a topic for a future episode. If you haven't already, consider subscribing so that you don't miss it. It was then a quick time warp to the unlocking of supersonic plane development, getting me, amongst other things, the high altitude X1 cockpit and the ability to perform air launches. This immediately got me building my own version of the Bell X1 rocket plane, a vehicle which is going to be the focus of the next episode. Also, while keeping a careful eye on budget, I hired 15 more researchers and 21 additional engineers to work on the X1, bringing my total staff to 136 and leaving the road clear to the XASR-1 mission. But let's first take the opportunity to take a look at the final version of my kOS mission script. And one thing to notice right away here is I did not have to go into the menu to find this terminal. It opened itself up automatically for me. As well, it automatically switched over to the archive for me rather than being on the vessel. That happened automatically through the magic of a boot file. So this is the boot file here. First of all, there are a couple of comments, which is unnecessary, but I like to have these up here, what the title of it is, and then a brief description, switches the volume to archive. And then we have the actual program, which you can see is not very long. It has an if statement. So what this means is if this particular condition turns out to be true, we're going to do the commands that are between these two curly braces that we see here in red. If this condition is not true, then it's not going to do anything at all. So it's looking at something called status. You've seen this before. Vessels have a variety of status like in orbit, splashdown, suborbital, in atmo, stuff like that. And one of those statuses is pre-launch. This is before you've actually launched the thing at all. So if the status is equal to pre-launch, then I want you to go to the core, the part, and to get the module. I know this is all really, but yeah, you can look at the documentation to get this specifically, but I want to get the module kOS processor. That is the actual terminal that you see, and do this particular event. Notice the colon, you have to be very careful with punctuation, and the event I want you to do is to open the terminal. This is the actual line that opens the terminal without me having to go through and find it in the game's menu. Then the next line is very familiar, switch to 0. That's exactly the line that you see me typing into the terminal. And then I have a print statement. A print statement will print something to the terminal. You put whatever it is you want to print in quotation marks, and in this case, the print statement simply says volume is switched to archive. It's always nice to give information to the user, that's you, as to what is going on. Now, if I wanted to, I could continue on. For instance, if I wanted to, I could type right in here, run XASR-1 that, and actually that would actually run the program without me having to do anything, but I kind of like putting that part in myself. But if you would like to do that, then by all means do so. Now, this file needs to be saved into a very specific location. There is a folder called the boot folder. This folder is in a folder called script, which you will find in the ship folder of your KSP game. So go to your KSP game, look for a folder called ships. Inside there'll be a folder called script if you have kOS installed, and inside that is another folder called boot, and any boot files you need to put into that boot folder. One thing that's very important about kOS scripts, if you are typing them in an external editor like I did here, is they need to have the extension .ks on the end of it. Once you have a file in your boot folder, if you right-click on where your kOS processor is, which in this rocket is in the avionics package, you will find some kOS information, and you will have this option here to select a boot file, and you can simply go through and select however many files there happen to be there. I only have one, but if there was more than one, you can go through and select them there, and that boot file is now stored in our avionics package. And with that, let's go take a look at our program. So I'm going to edit, once again, SAXR1, and there it is down here. And it's been dressed up a little bit, but it's not too bad. Let's see if we can get it so we can see the whole, that is the whole thing right there. So first of all, I want to point out the stuff that you have already seen. So if we sneak all the way down here, we have the command to stage. Don't worry about this, I'll get to it in just a second. It's really window dressing. The important stuff is down here. We're going to stage, then we're going to wait until our vertical speed is less than 0, at which point we're going to stage again, and the idea of that is for it to stage the parachute. Unfortunately, sometimes with KSP, you've ever noticed you have to stage twice, and I've never puzzled out why you do have to stage twice. And this is one of those situations where the parachute wouldn't deploy just staging it once, so I had to put in a second stage. Again, this is a KSP thing that I've never been able to quite figure out. And I needed to put a delay between the two stages. If you go stage, it actually doesn't do the second stage. So I put a wait 2 seconds between the two stages, and that arms the parachutes. And that actually accomplishes just these 5 lines right here, the entire mission. The rest of this is window dressing, so let's go take a look at some of this window dressing. One, I put in a few print commands to put some information out towards the user. So for instance, here it says print, and there's a space here, it just prints a blank line just to separate it from the stuff that came before, and then it's going to print that the parachutes are armed. It's going to wait a second, and then I'm printing out program shutting down, good luck, and of course after that the program ends. This stuff all at the beginning is actually to provide a bit of a countdown. Let's take a look at it. Well, first of all, right at the top, I have this command to clear the screen. That's a really nice command to put right at the very beginning of your programs. It clears all the other nonsense that was there before, starts you with a blank screen. Wait a second, and then to play, there's a thing called voice and a command called play and tick note. So tick note is defined up here. Tick note is an example of what's called a variable, something that you write into your program that holds a bit of information, and then you can keep referring to it. You can see there's a few tick notes going down here, and up here is where I tell it what tick note is. Tick note, it uses the word set to give a value to a variable. So I want to set tick note to, and then there's a command here called note. A note is simply a tone. That's all it is. And then you put in the frequency of that tone, 480 hertz in this case, and then how long you want the tone to play for. In this case, just 1/10 of a second. So tick note is just a tone at a frequency of 480 hertz that plays for 1/10 of a second. If I wanted to, I could have put this whole command here right here in for tick note, and it would work just as well. But it's easier to actually create a variable and then use that variable multiple times. So what's going to happen here? It waits for a second, and then it plays a tone, and then it prints 5, and then it waits for a second and plays that tone again, and then goes 4. I think you're getting the idea. Wait one more second, play the tone, and then go 3. Yes, this is a countdown. That's what's going on here. Then it's going to wait half a second, lock the throttle to 1. Remember, that's necessary for the Aerobee engine. Then it's going to print the message out, throttle locked to full, and then it's going to wait another half a second so that this part takes a second, and then it's going to print, tone 2, wait, tone 1, wait one more second, then it's going to print the word launch, and then it's going to print a separate tone, which is called launch tone, and launch tone again is defined up here. It is a tone of 720 hertz that's played for half a second, so longer than this particular one. The other thing that's defined down here, by the way, is the word voice. Voice is not a kOS specific thing, and voice up here has been set to a command called get voice, which is just the kOS way of saying I need you to go out there and I need you to get sounds. That's the command that does it. And then the rest of this should all be very familiar. So again, most of this program is actually window dressing. This is the guts of it down here. Very simple little program. So let's see it put into action. And we're off. Remember that I do have a contract to reach space, which is an altitude of 140 kilometers, and then return the vessel safely. No, programming in kOS isn't for everybody, and isn't necessary to play RP-1, or for that matter, regular KSP, as kOS works fine in that too. But for some of us, writing your own scripts to automate missions is very satisfying. Also, for those that are unfamiliar with programming, this may seem very intimidating. Though KerbalScript is deliberately more clunky than modern programming languages like Python, if learning how to program rockets is a hook for you to get into coding, kOS can be that entry drug into a whole new world. This episode aside, I do not intend to make full kOS tutorials within this series. If you are interested in learning more, I would highly recommend Cheers Kevin's excellent kOS for Newbies series. Link in the description. You know what I do like about this is that kOS is like, I don't know, I find in a game like this, when you're playing with Kerbal construction time, you build something and then it's like not the same day that you fly it and that you plan out your mission. It's later on and you do other stuff in between. And I end up forgetting kind of what the mission plan was. And what's nice about this is you can just make it so that you just run the program and it does the mission. I find that comforting. Hey, and I'm getting scared, but one day I'm going to get burned when I'm not expecting it, but 8th launch in a row. No, there we go. And that is our parachutes are armed. Program is shutting down. Good luck. We do not need electricity. We got 2 science out of the deal. I'm good with that. And jeepers creepers. Hopefully we'll be in the water. There goes the tail fins. Again, that is a feature, not a bug. As this thing starts to, now it'll lose speed more easily. As it, yeah. Oh my gosh, not as easily as I hoped though. I guess the longer tank is contributing to this. I think so. That makes sense. Okay, we are going in the water, just offshore. Easy recovery as long as... This is scary as heck. We're good. We're good. I hope this episode didn't represent too much of a diversion from what you've come to expect from this series, especially for those that aren't interested in the kOS mod. Next episode will see us return to normal as we try to break the sound barrier in the X-1 rocket plane. And don't forget, there is a larger V2 rocket on the way as well. In the meantime, let me know what you think, and as always, I want to thank you for watching and hope to see you again next time.